All right, enzymes. What are they and how do they work? Um, well, enzymes are a class of chemicals known as catalysts. And the most important thing to know is that enzymes, which are catalysts, they speed up reactions. And so I'm going to abbreviate reactions as RXN. All right, now the way they do that, the way they speed up reactions is by lowering what's called the activation energy. All right, so this is the number two, maybe important thing to know from this. Activation energy refers to the energy required by the reaction to proceed. And so, for example, if we take like substance A turning into substance B, let's label these reactants is what we would call the substances before the reaction, and then what they produce we call the products. So in a chemical reaction, when something when reactants turn into products, it requires a certain amount of energy. And what enzymes do is they'll make it easier for the reactants to turn into products. Okay, and one more thing to note is that the concentration of enzymes, concentration does not change. In a reaction, the amount of reactants, the concentration, the amount will decrease because they're getting used up, whereas the products will increase because they're being produced. Enzymes are not reactants nor products. So oftentimes you'll see them written on the arrow to indicate that they're not being used up. All right, so the amount of enzymes you have at the beginning of the reaction is the same amount that you have at the end. All right, so let's illustrate this using an energy diagram. All right, so we have along the y-axis we'll label that energy, and along the x-axis we'll label this the progress or the reaction. All right, so the reaction progress. All right. We're going to give the reactants that's the beginning substances. We'll say they have a certain amount of energy and they need to have they need a certain amount of energy for the reactants to proceed into the products, to turn into the products. Now, this is not to say reactants are always higher in energy than the products, or now they can be other ways, but this is just a common way that you might see. Anyway, the important thing here is this part. All right, that hill that the reactants have to overcome to become products, that's known as the activation energy. All right, so let's just say a certain reaction requires a certain amount of activation energy, and because it requires that energy, it might happen at a much slower rate. Now, with an enzyme present, that activation energy is much less, right? So it's much lower. So this blue line represents with an enzyme. Okay. So that's what we mean by lowering the activation energy. And so because this reaction now requires much less energy to proceed, right? It's going to happen faster. All right, so that's important that you're able to maybe even draw this out from memory, but at least interpret it. I drew this too, but imagine somebody at point A, and there's a mountain in the way and that person has to get to point B. And the only way is to go over the mountain. So that's going to require a lot of time and a lot of energy. Now, what a tunnel can do, a tunnel is like an enzyme, right? The tunnel gives this person a faster route and an easier route. So does the tunnel provide energy? No. Right, so don't say proteins provide energy. Enzymes are proteins. Remember, those are forbidden words. But the tunnel does lower the energy required for the person to get from point A to point B. So if that helps, you can think of it, use that analogy where the enzymes are like a tunnel, just providing a faster access, faster route from point A to point B. Reactants to products. Okay, so I'm going to draw one more illustration here to show you what this might look like. Oftentimes, proteins are so complex that it's hard to draw them, even with computers, because it just looks like a mess. But we'll often simplify these shapes. So we'll say this is an enzyme. Right, so what we're stressing here is that it has a very important structure, right there, and that's where it will catalyze the reaction. And so this is very important. This is known as the active site. Okay, so in an enzyme reaction, the reactants are sometimes called substrates. All right, so in this case, this is the substrate, and this is not drawn to scale. Enzymes proteins are huge molecules, and sometimes these substrates are much smaller. But the point here is the substrate, in order for the enzyme to catalyze the substrate, that active site has to match the substrate structure. So notice that in this case it can, and so what's going to happen here is the substrate will bind and form this enzyme substrate complex. And then once it binds, the enzyme will change shapes, will undergo some changes, and that'll allow the substrate to undergo its changes as well. There's several ways that enzymes work, but this is just one of the common ways that we show. All right, and then that is going to release the substrate as products. So now you have, in this case, the substrate is being broken down, but that's not always what happens. Enzymes don't always help break things down. Sometimes they can help form things. But again, this is just a very common example. All right, so these are known as now the products. Right. So you have your reactants, aka substrate, and then you have your products. And now this enzyme is free to catalyze more substrate. So notice the enzyme did not change. You didn't get less of it. You didn't use it up. But certainly the substrate quantity, the concentration will decrease, and the products will increase. Okay, one more thing I want to add to this is that there are factors that could cause an enzyme to break. We call that denature. Right, and the two factors are changes in temperature and pH, right? And for different reasons. But what you need to know is that when the temperature inside an organism or the pH inside the organism changes too far from its normal range, then the active site will change. And if the active site changes, the substrate can't bind to it, and then the enzyme can't do its job, which can lead to death. So that's also very important to know. All right? The factors that could cause an enzyme to denature, and it's specifically the active site that it changes, or changes in temperature and pH.